Okay, this presentation is all about atomic structure, so we're going to be looking in detail about the structure of the atom. Before we get going, I just want to have a little bit of a think about the periodic table. So I'm going to pop a copy of the periodic table on screen in a second. What I'd like you to do is use that, just have a look at it and see if you can find any atoms or elements named after people or places. So there's the periodic table, so you might want to pause the video, just take a minute or two, have a look through it and see what you can find, and then we'll come back and have a look at any atoms or elements that you may have found, and I'll put up a few that I've found. Okay, first one to draw your attention is scandium. That's named after Scandinavia, where it was discovered. We've then got germanium. This is named after the birthplace of Clemens Winkler, who discovered germanium. He named it after the country of his birth. Then we've got copernicium, named after Nicholas Copernicus, the Polish astronomer. Moving on from that, we've got bohrium, named after Niels Bohr, who was Danish. Then we've got rutherfordium. Ernest Rutherford was a New Zealand physicist, and he named this one. And then we have polonium. Marie Curie, one of the most famous female scientists, that we know about. Her work with radioactivity, along with Pierre Curie, was very well known, and we still look at it today. And this was named after her birthplace in Poland. So, as I say, the presentation is all about the structure of the atom and learning to understand a little bit more about it. So for a grade 3, you just simply need to be able to remember the names and locations of the subatomic particles. So just a very basic recall for a grade 3. For a grade 4, it ups the level of demand slightly. You've got to be able to describe the mass and charge of the 3 subatomic particles. And finally, we're just going to go a little bit, not lots, but a little bit of detail about how and why and where the periodic table is split into different parts, and that's sort of getting toward the grade 5 plus level there. Why do we need to know it? Atomic structure and periodic table is fundamental. Without knowing about the periodic table and atomic structure, we really wouldn't know much about anything in chemistry, whether that's states of matter, bonding and chemical change, all of that be non-existent. So this knowledge and understanding of the atom and subsequent the periodic table, it's only really been gained in the last 200 years or so. And obviously, if anybody watching this is wanting to go into a career involving chemistry in any format, then you've got to have a basic fundamental understanding of the periodic table and atomic structure, because it does underpin all things chemistry. So whatever your career goal is, you can't go on to anything further in chemistry without having a really good knowledge of the periodic table and atomic structure. So in terms of atoms, we use this phrase quite a lot, that atoms are the building blocks of life. They make up everything. Whatever you're watching this on, whether it's a laptop or a mobile phone screen, everything that's ever existed, that currently exists, that will exist in the future, it's all made from one of or a combination of more than one of those 100 atoms that are found in the periodic table. So like I say, the screen that you're watching this on, the chair or whatever you sat on, the table that you're leaning against, the cup that you're drinking your drink out of, everything is made from those 100 plus atoms in the periodic table. It could be one of those on their own. So if you are hammering an iron nail into a piece of wood, that's just made out of billions and billions of atoms of iron. Or whether you're drinking some water, which is made up of a combination of hydrogen and oxygen atoms. But all of those materials are made from the same simple building blocks that come from that periodic table of 100 or so elements. Now we know that atoms are the smallest parts of elements that can exist, so we can keep dividing an element down if it's made of only one type of atom, and we'll come down to one single atom of that element. And elements can have lots of different properties. So we can have solid elements, we can have liquid elements, we can have gaseous elements, we have metals, non-metals. So we're just going to have a quick look at that periodic table again to bring this together a little bit more. This is the periodic table that you get in your examination at GCSE, and it's the one that we use in school all the time and you'd be familiar with. So it should hopefully look very familiar. There is another video that you can access that's all about the periodic table in a bit more detail, so please take the time to look at that. I'm not going to go through the periodic table in lots of detail. First thing I just wanted to draw to your attention was this. Along the top you have numbers, so 1, 2, 3, 4, all the way up to 7 and then 0. These are what we call groups. Now all elements in a group have something in common, and what they have in common is they have the same number of electrons in their outer shell. So in group 1 that we can see there, with lithium, sodium, potassium, rubidium, cesium and francium, all of those elements have common chemical properties, but they also have one electron in their outer shell, which is why they're in group 1. Same goes for group 2. So beryllium, magnesium, calcium and so on, they will all have 2 electrons in their outside shell, and they will also behave in similar ways chemically. The other distinction I'd like to draw your attention to is if we look at this zigzaggy line that's breaking the periodic table into two uneven halves. So we've got the larger half to the left of the zigzag line. All of those elements there are metals. If we just ignore hydrogen floating up here for now, so everything here, they are all metals. And everything to the right of that zigzaggy line, they are all non-metals. So it's just a couple of little bits about the periodic table that are relevant to this presentation. So in terms of the structure of the atom, with regards to the atom, we know that they can exist because of electrostatic forces of attraction. Basically, that's an invisible non-contact force that keeps an atom together. It keeps everything together in an atom. Now, I just want to take you back a little bit to sort of primary school, maybe year 7 and 8, and think about magnetism. When you bring magnets together, and I'm sure you've all done this practical before, we know that magnets have a north pole and a south pole. So I just want you to take a few minutes. So again, you might just want to pause the video at this point, have a think about these 3 statements and what happens when you bring 2 north poles together, 2 south poles together, and a north and a south pole, or a south and a north pole are brought together. So just pause the video now, take a couple of minutes, have a think about when you've done this in the past, what happens with magnets. Okay, hopefully it wasn't too difficult for you that, and you've managed to think back. But yeah, when you bring 2 north poles together, you actually get repulsive force. What happens is the magnets push away from each other. So those 2 magnets with their north poles coming together, they push away and there is repulsion. Same goes with 2 south poles. Again, you would get repulsion. So what we say in terms of magnetism is that like poles repel. Basically 2 of the same push away. But when you bring the north and the south pole together, or the south and the north pole together, you actually get attraction. There are attractive forces between the north and south pole. Now, if we take this at an atomic level, it's kind of the same sort of idea. Atoms have smaller subatomic particles, and these have a charge. So they could have a positive charge or a negative charge, and they work a little bit like magnetic poles in so much as if the charges are opposite, so if you have a plus and a minus or a positive and a negative, then they will be attracted to each other, a little bit like a north and south pole. But if the charges are the same, so a plus and a minus, they will repel and push away from each other. In terms of the subatomic particles then, we know that there are 3 subatomic particles that exist in an atom. We have protons, we have neutrons, and we have electrons. We know that protons have a positive charge and they are found in the nucleus. Now, a nice little way to remember that is proton begins with P and the word positive begins with P. So it's just a little way to get you started on remembering those. So protons are positive and are found in the nucleus. Neutrons are neutral. So again, a little way to remember it. Neutrons, neutral, N and N. What that means, neutral, it means they're not positive, they're not negative. They're somewhere in the middle, so they don't have any attraction or repulsion to anything else because they don't have a charge to attract or repel against. And they're also found in the nucleus, So it means overall, if we just take the nucleus has got a positive charge because inside the nucleus we only have 2 things, positive protons and the chargeless or neutral neutrons. So the only things with charge in the nucleus are positive protons, so it means that the nucleus is overall positive. The electrons, they're negatively charged and they're found in electron shells or energy levels, and the energy level closest to the nucleus has the least energy, and as you move further away from the nucleus, the energy level of that energy shell increases and gets higher and higher. But those electrons are found in shells. So it means that when you think about an atom, you've got an attraction because you've got a positive nucleus with the protons in it, and what that's doing is holding those electron shells, it's pulling those electrons to it with an attractive force, which we've already called electrostatic forces of attraction. So if we talk about the mass of the subatomic particles now, what we're talking about is relativity. We don't say, they weigh 17 grams or anything like that. We talk about the mass relative to other subatomic particles. So protons and neutrons, we say, have a mass of 1, a relative mass of 1. No units. We're not talking kilograms. We're not talking grams. We're not talking tons. Basically, it's just showing us that a proton and neutron have the same mass relative to one another. They are essentially the same mass of 1. Electrons, on the other hand, we say they have a mass of almost 0. If we're going to be technical, it's actually around about 1,840th of the mass of a proton or neutron. Depending which textbook or website you look at, that number may differ slightly. It may be 1865, but it's there or thereabouts. What that means is, if you wanted to have the number of electrons to equal the mass of a proton or a neutron, you would need 1,840, so a lot. What I'd like you to do now, there's a table here which just summarises all that information. So just take a couple of minutes to copy the table down, and then have a pause of the video, move back a few slides, have a little bit of a rewind, and see if you can populate that table just to summarise all that knowledge. So couple of minutes to copy the table down, then pause the video and obviously have a go at filling that out, and we'll go through it next. Okay, hopefully you found that quite challenging, just going back through and having a look at that. Here are what I would be hoping you have populated that with. So 3 subatomic particles on the left hand side, the proton, neutron and electron. We can see that the charge of a proton is positive, or a plus. It has a relative mass of 1 and it's found in the nucleus. The neutron has a neutral charge. It also has a mass of 1 and it's also found in the nucleus. And then the electron has a negative charge. Its mass is almost 0, and you are fine to quote that mass as almost 0. If you can remember the 1/1840, brilliant, but you will not get any loss of credit if you just say almost 0 for the mass of an electron in an exam. And the electrons are found in those shells or energy levels. Okay, what I'd like you to do now, on screen there are a couple of paragraphs where you are given some hints, and this is all about charge and particles that we've just looked at. So it's just for you to have a go to see what you can remember. So again, take a few minutes to copy the paragraph down, and then you can have a go at this. Obviously, pause the video, go back, have a look and see if you can fill in those gaps, and then we will go through it. So just take the time to copy it and fill it in, and then we'll have a go through that. So if you want to pause the video now. Okay, again, a little bit challenge there for you, so hopefully you were able to complete that. So we'll just talk it through. The missing words are the words written in black in the paragraph, so I'll just pop all those up there. So we can see, like it says, all particles have charge. It's a property that can be positive, negative or neutral. Positive charges attract negative ones or negative charges and repel positive ones. So again, like we talked about the idea of magnetism with opposites attract and like repel, it's the same sort of thing here. Neutral charges not attracted or repelled because they're not positive, they're not negative. That was the discovery of charge that allowed scientists to develop their model of the atom, and there is another video that you can watch, another presentation that looks at how the models of the atom have changed over time. And this is a key part here, this idea of a model. We use models a lot in science. A lot of science is hard to see. As we're talking biology and we're talking about a lot of things that we can see because we're talking about plants and animals and living things, but a lot of science, chemistry and physics in particular, is theoretical. We can't actually see it. It might be something too small or something that we can't actually see happening. So what scientists do is develop a model, and a model is just used to back up a theory. So it's another way of thinking in a non-scientific way possibly, and we use it to describe things which can't be observed directly. Okay, just to finish off then, there's a past paper question from a previous GCSE examination. I'd just like you to take a bit of time now to have a look through it. So it's to do with atoms, and we can see there 4 atoms, A, B, C and D. So just have a go at answering those. They're only very, very low stakes retrieval type questions, so just requiring a very, very brief answer. So take a few minutes again. You might want to just pause the video to have a go at answering those, and then we will go through the answers to finish off. Okay, taking answer A then. Name the 2 subatomic particles in the nucleus of an atom. So a nice straightforward introduction to this question, and hopefully you've got the answer: protons and neutrons. Now this is key. It does say in the question, name the 2 subatomic particles. Sorry about that. So it does say protons and neutrons, and both are needed for the mark. So if you did just say protons or neutrons, you would not get the mark in an exam, and this is a very, very common mistake. It's just a case of reading the question. The other information here is guidance for the examiner, the person marking the paper, and as it says, ignore P and N. So if you just put P and N on, it's unfortunate. You do know what you're talking about. You know it's P and N, protons and neutrons, but for the level of demand of the question, unfortunately, you wouldn't get it. You do have to say protons and neutrons, and clearly any reference to electrons isn't acceptable. For question B, why is there no overall electrical charge on each atom? This is where we looked at charge as part of the presentation, and if you remember, we talked about charge and positive protons and negative electrons, and if you remember, when we look at it, we know that when you have an atom, the number of protons in the nucleus is equal to the number of electrons, because they have to balance out, they have to cancel each other out. If we had more electrons or more protons, we wouldn't have that balance with the atom, and we wouldn't have those equal electrostatic forces of attraction. So the sort of model answer, if you like, is because the number of protons is equal to the number of electrons. However, you would also get credit if you said protons and electrons balance, protons and electrons cancel out, or the positive and negative charges balance and cancel out. So either of those would be allowed. Part C now. So there it says, why is atom A unreactive? This brings us back to when we looked at the periodic table, and we talked about electron shells briefly, and there is another presentation on electron shells and things like that, so it might be worth having a look at that. So this is a bit of an interleaving question, just revisiting a bit of old knowledge. So if we look at atom A, we can see it has 2 electrons, and those 2 electrons are occupying for that atom the highest energy level. In this case, it's the first shell. Now hopefully you can remember that the first shell can only hold 2 electrons and then it's full. So atom A has got its 2 electrons occupying its highest energy level. It can't fit in any more electrons, and that means it's full. So if we were to get another atom B and add another electron in, we have to then go to the next highest energy level and start to fill that shell. So if we look at why atom A is unreactive, as it says, because it has a full highest energy level, more simply, as a full outer shell. You could also say all the electron shells are full, or because there's no incomplete shell or there are no gaps in the shell. You could say atom A has a stable arrangement of electrons, or you could also say that atom A is in group 0 or it's a noble gas. But basically, the key thing is it has a full outer shell. And finally, question D, this is a 2 marker. It's quite a bit of space here. Please don't be put off by the space. Sometimes it's about the quality of the answer, not the quantity of what you write. Did give you enough space just in case you do tend to waffle your answers, but that's fine. Just make use of the space if needs be. So which of these 2 atoms have similar chemical properties? And then this is the key bit. Give a reason for your answer. So you can't just say 2 letters and leave it at that. You've got to give a reason. Now, straight away, when we looked at the periodic table and we talked about groups and earlier in the presentation, and atoms in the same group or elements in the same group have similar chemical properties and the same number of electrons in their outer shell, I'm drawn to atom B and C, because we can see here atom B has 1 electron in its outer shell, and atom C also has 1 electron in its outer shell. So that tells me they're going to be in the same group. Now if we look at the mark scheme, it pretty much says that. So for 1 mark, you're identifying atom B and atom C. Now the mark scheme also names them lithium and sodium, or Li and Na. You don't have to state lithium and sodium if you don't wish, because the question does say which two atoms, and in the question the atoms are named as B and C. It's just if you wanted to take it that step further, you don't get any more marks or any less marks. B and C is perfectly acceptable. So you get the first mark there for identifying them. The second mark then is for giving that reason why, as it says in the question. So the key answer is they have the same number of outer electrons, or they have the same number of electrons in the outer shell. A few more detailed answers that people have put in the past, and you might say because both need to lose an electron. This comes in when we're talking about ion formation and ionic bonding, so don't worry too much if you don't understand that statement at this stage. This is one of the answers we've just discussed, because atoms B and C are in group 1 or are in the same group or are alkali metals. But at its simplest level, you could just be putting like atom B and C because they both have 1 electron in their outer shell, or they are both in group 1. Okay, so just to summarise then, the key learning from this video. Obviously we've talked through atomic structure. The key things that you need to remember from this are the idea of charge and the fact that we have protons, neutrons and electrons. You need to remember the mass, charge and location of those protons, neutrons and electrons. And with regard to the periodic table, you also need to have that understanding of how the periodic table is arranged, both in terms of groups of common elements with the same number of electrons in their outer shell, but also that metal and non-metal split.